Welcome everyone. On behalf of the Solar Boat Twente team, we would like to thank you all for joining us here at our concept review. My name is Bram and my role covers external affairs, overseeing external relations and partnerships on behalf of the team. Or as my team members like to say, I send out a lot of emails and invite people for a coffee. This year, we are taking the next step to innovating the maritime sector, together with this wonderful group of 22 enthusiastic, highly motivated students. Together, we will present our plans for this year right here on this stage. Before we do this, we would like to thank all of you, our dedicated partners. We are also thrilled to welcome our new partners on board. The enthusiastic response to the switch to this next chapter has been incredibly inspiring. This new direction brings fresh energy to not only our boat's development, but also to our team spirit. With these new alliances and the strength of our long-term partners, we are ready to grow. Together, we can build a future where innovation and progress move forward as one. Before we start looking at the future, let's first look back at our solar boat era. For this, I would like to invite the management team to the stage.
Thank you, Bram. My name is Guusje, and together with Pepijn and Balder, we form the management team of Solar Boat Twente. As the management team, we are responsible for guiding and supporting this ambitious project. As team manager, my role is to keep the entire team aligned. That means that I oversee both our short and long-term goals, while also ensuring the well-being within the team.
As technical manager, I oversee the technical side of our project, making sure resources and knowledge is shared where needed, and making sure deadlines are met on time. Ultimately, my role is to ensure that our technical ambitions don't remain ideas on paper, but become a foiling boat.
As financial and operational manager, I bridge the gap between the team and the outside world while maintaining financial health. By aligning the finances and the operations, I both secure resources and visibility to keep the project moving forward. Before we are moving forward, I want to take a moment to reflect how we laid the foundation as Solar Boat. Since our founding in 2016, Solar Boat has had a massive technological transformation.
It all began with Conrad. As our very first boat, it was the proof of concept that could compete using nothing but the power of the sun. But most importantly, it was the start of a learning process. With Conrad, we were mastering the basics, building a hull, integrating solar panels, and managing a battery system under race conditions.
With Aquila, our last solar boat, we have taken the solar boat as far as it can go in terms of major innovations. In the 8 years between Conrad and Aquila, each component has been improved, redesigned and optimized to reach the limits of performance and efficiency. Following our motto, innovation to inspire, we felt like a change was needed in our project.
And that brings us to today. We are a team driven by innovation and we are never finished. We are taking the lessons learned from the past, we are applying them to the challenges of today.
This year, we are moving beyond solar panels. This is a massive technological step, and so I am very proud to say that we aim to be the first student team in history to build a boat powered by green methanol.
Now, this decision, of course, comes with a few technical challenges. The first of these challenges are that the size and consequently the weight of our components and boat will increase. But our most important challenge is ensuring the safety of the systems on board and the people working on the boat. How we exactly will face these challenges, I will leave to the engineers to explain. However, what I can tell you are our technical goals of this year. Since this is the biggest transition and change Solar Boat Twente has seen since its founding, this year's boat will serve as a proof of concept, prioritizing reliability and robustness above performance and efficiency. Now, we also, next to building a boat, they focus, by showing that in just 1 year we can build a completely new boat with a powered by a methanol fuel cell. we want to prove that the future of this team is exciting and promising. And yes, you heard it correctly. We want to make our boats foil this year too. Making our boats fly is part of our identity as Solarboat Twente and shows our ambition to keep on innovating. This year's boat will be designed to have a takeoff speed of 26 kilometers an hour and will be able to foil for at least 1 full hour. Now, next to building a boat, we also focus on putting down a foundation for the future. Due to the new circumstances and challenges faced, documentation of the engineering processes is extra important this year. And as if building one boat was not enough for us, we're also designing a completely new hull that will be produced in the near future. Looking even further ahead, we have started research on a more powerful fuel cell system that will be developed by ourselves in the future. Now, let's not get carried away by our ambitious plans and take a step back and look at this year. And maybe even a bit before that. Because you might be wondering, why did we actually transition to methanol? And to answer that, I would like to welcome our newest sub-team to the stage, Power System.
Yeah, thank you, Pepijn. We are indeed the newest sub-team of Solarboat Twente. We are the very first Power System sub-team of many to come. My name is Frits, and next to me is Daan, and together with Marina and Twan, we are responsible for converting green methanol into electrical power. Before we go deeper into what we actually do as Power System engineers, we would like to convince you that methanol is the way to go and why racing boats powered by methanol is such an amazing project.
As you all know, the last years we powered boats with solar panels. But imagine you want to power a big container ship only with solar panels. Let's fill the entire boat surface with solar panels. Would this be sufficient? Indeed, no. It's not even close. It takes approximately 11 decks completely covered with solar panels on a beautiful clear day to fully power one ship. Solar panels really have their place in the energy transition, but not as direct power source for the maritime industry. The maritime industry is exploring different options. Currently, the most popular and realistic options are hydrogen, ammonia, and methanol. But you have Frits. Why did Solarboat pick methanol specifically?
Well done. There are mainly two reasons why we chose for methanol as our future. The first being sustainability. When produced as green methanol, it can be considered carbon neutral on a life cycle basis, meaning that CO2 emissions can be significantly reduced. And as a bonus, compared to traditional fossil fuels, the emission of common pollutants in the maritime industry can be almost eliminated. Furthermore, methanol is also less toxic for marine life than for example, ammonia or other fossil fuels. It is even 1,000 times less toxic for marine life than diesel. And methanol is also biodegradable. And in an unfortunate event of spilling, it can be fully reversed within a few weeks. This as opposed to diesel or heavy fuel oil that takes ages to even clean up. The other reason why we chose methanol is scalability. Unlike hydrogen and ammonia, methanol is actually liquid at room temperature. It means that it takes up much less space to store, and it is easier to handle. I have a fun fact actually. Did you know that methanol is one of the oldest chemicals to be researched by humankind? And you might ask yourself, well, Frits, why does it matter? Well, one of the things you don't really think about, but is crucial when implementing a new fuel in the maritime industry, is making safety regulations. And because methanol can be backed up with so much research, it is relatively fast and easy to make those safety regulations. Also, ships' engines nowadays can already run on a combination of diesel and methanol. And with a bit more tweaking, it can even almost fully run on methanol. This makes the transition for companies much easier. And all this together means that methanol is ready to become a fuel for the maritime industry within already 5 years. Now, you can use a few different methods of powering a boat with methanol, but I won't bore you all with explaining each and every one of them because, well, that's boring. We're going to stick with the ones that is the most efficient, and we think we can innovate in the most. And personally, I also think it's the most interesting. Well, Dan, I think it's time for a review, right?
Let's go.
The thing that makes it all possible. What an absolute beauty, isn't it?
But Fritz, for most people it's just a box. Doesn't look that interesting from the outside, does it? Let's quickly look at what's in the inside. This mysterious machine essentially contains a reformer and a fuel cell. Both the reformer and the fuel cell ensure that when we put methanol in, electricity comes out. Surprise! The machine is called a reformed methanol fuel cell. We will work with a mixture of methanol and water. In the reformer, the methanol and water are first converted into hydrogen and CO2. And the mixture of hydrogen and CO2 then enters a fuel cell together with an airstream. And in that fuel cell, the hydrogen and oxygen of the air produce electrical power when they react. Hydrogen is thus directly produced and consumed on the spot, and this omits the difficulties with hydrogen storage. For the fuel cell, this is just the tip of the iceberg. And as Power Systems Subteam, our main goal this year is to integrate the fuel cell into our new boat. And with this goal, we aim to stimulate the deployment of alternative fuels in the maritime industry, aligning with our team's motto, innovation to inspire. There's only one problem. The fuel cell that we have doesn't fit into the latest solar boat. But that's a problem to be solved by our structural subteam, and therefore I gladly introduce Koen to the stage.
Yeah, thank you, Dan. So hi everyone, I'm Koen, and together with Pieter and Maaike, we formed the structural subteam this year. So, as we already told you, we are going through a super exciting transition this year. But the power source is not the only thing changing. We're also changing the entire boat. So let's actually have a look at the boat we will be using this year. There it is. But before we will tell you all about this new boat, let's first get an overview of what we as a structural subteam actually do. So we basically have 3 main responsibilities. And the first, you just saw, is the hull of the boat. Second, we're also responsible for the cooling. And lastly, we're responsible for the cockpit. So to make it easy and make it clear for you, let's just go through them one by one. Starting with the hull. The hull is the main body of the boat. It gives the boat its structure, it depends on how it looks, and maybe for us, most important, it gives us the opportunity to show the logos of our great partners. So, as I mentioned, the boat is changing this year. But what is actually changing? Well, let's do a quick comparison. As we see on the top, this is Aquila, our last solar boat. And we can see on the bottom our current boat. The first thing that comes to mind is the size. Our current boat is a lot deeper and it's also a bit longer. Another thing that's changing this year is the weight. Aquila was ready to sail at 180 kilograms, which is, by the way, super light for a sailing boat. And at the bottom, our current boat is ready to sail at 1,000 kilograms. Next to all these physical things, also the way of using our boat has changed. With Aquila, we always sailed on relatively calm waters. We sailed on lakes or within marinas, but nothing too rough. And with our current boat, we will actually go into the open sea, which means we need a stronger boat. And this size and weight difference are mainly due to 2 things. But to see them, we have to flip the boats around. So let's quickly do that. There we go. we can see that Aquila is a trimaran design, which just means we have one main body and two side floaters. This was to increase the area of the top deck so we could put as many solar panels as possible on the deck. But now with the elimination of these solar panels, this is not really necessary anymore. So we switched to a more traditional monohull, which just means one hull. This monohull gives us the opportunity to fit our larger and heavier components in the boat. Next to this, we also have a super exciting challenge as a structural sub-team this year. We are designing a completely new boat from scratch. We are doing this to further improve our efficiency and to suit our own wishes even better. And we are aiming for the production of this boat already at the end of 2026. So okay, enough about the hull. Let's go to the next main responsibility, the cooling. Why do you even need the cooling? Well, we're a racing boat, which means all of our components are operating at their maximum capacity, which is very bad for the components. In the best case, it lowers the efficiency. In the worst case, it can actually permanently damage our components. So we try to control this heat. We do this with our water cooling system. So we pump up the water that we're sailing in. For us, it's the seawater. We pump it through the components, thereby cooling our components, heating up the water, but we disregard that water. And that's how we keep our components at a low and steady temperature. Then, our last responsibility, the cockpit. The bond between our pilots and the boat is already super great, of course, but to actually operate the boat, they still need some instruments. So let's have a look at the cockpit. As you can see, we have all the basic things, like a steering wheel and a throttle, to change the heading, the direction you're headed to and the speed that you're sailing at. But we also have a bit more complex systems. We have a button box, so the pilots can always change the settings of the boat. And we have multiple displays. These displays are, first off, to show the speed and the direction you're going in, but also to show all our safety measurements. So the pilots can ensure that our electrical and our methanol systems are working properly. Basically, what we do as a structural sub-team is make sure that the pilots can operate this boat as efficiently and as safely as possible. So now that we have finished all these three main responsibilities, there's only one thing left to do. We need to integrate our components. And for us, it means getting an overview of what actually needs to be in the boat. How big is everything? How heavy is everything? And where does it even fit? And also with this integration comes a lot of cable management. Of course, the components need power. So I would like to welcome Kim to the stage. Kim, would you please tell everyone on how you make sure that every component has its required power?
Thank you very much, Koen. So this year, Duku and I, we formed the electrical sub-team. This means we're responsible for both designing and implementing all electrical components around the boat, as well as ensuring they all work together accordingly. Now, as previously mentioned, this year we are transitioning from solar power to methanol power. This is a huge step forward in performance, as we obtain 3.5 times more power. Now, because of this huge increase, we will not only be obtaining higher power, we'll also be working with a higher voltage. Previously, with solar panels, we'd be running with 60 volts, whereas now the fuel cell will produce up to 480 volts. But because of this steep increase, our old low voltage battery is too small and will not be able to handle the high voltage from the fuel cell. So we will be integrating an entirely new high voltage battery, designed specifically for the new architecture and with a larger energy capacity to propel the boat forward. Now, where will our old low voltage battery go, you may ask yourself? Volta, our old low voltage battery, won't be discarded. Instead, it will be repurposed to power the auxiliary system. And this involves powering sensors, actuators, controllers, and even the communication equipment. Now, this low voltage system will be completely separate to the high voltage system. This will allow the pilot to stay in communication with the shore team in the case of any high voltage line failure. Alongside this new battery system, we'll also be integrating an insulation monitoring device, or IMD. And this will monitor for any short circuits within our system. This will ensure the pilot is safe if any component were to fail. Alongside this, we will also be integrating a new and more powerful motor controller. This motor controller will communicate with the motor and will allow us to sail as efficiently as possible. Now we have a new, higher voltage, more power, and an entirely new and adapted battery system. But we need to be able to use this power efficiently in order to propel the boat forward. So Hessel from Propulsion will tell you all about it.
Thank you, Kim. My name is Hessel, and together with Thijs, we are responsible for the propulsion system of the boat. In short, this means our task is to convert the electrical energy into a forwards motion. It all starts with the motor. When it spins, that motion has to reach the propeller to drive the boat forward. We transfer the motion from the motor through this shaft to the gearbox. In the gearbox, the gears redirect that motion towards the propeller, making it rotate and allowing us to drive the boat forwards. This year is particularly exciting for us as we are implementing a completely new propulsion system. Where in previous years it was around 80 centimeters long, this year it will extend all the way up to 150 centimeters. But not only the size has changed, also the power delivery has increased significantly. The motor we will be using will have 10 times as much power as the motors we have used in our previous solar-powered boats. The new motor will deliver peak power outputs up to 60 kilowatts. This is equivalent to around 80 horsepower, 60 microwaves, or making everyone in this room a cup of coffee at the same time. Arguably the best use of electricity if you ask me. But you might be wondering, why not simply make a direct connection between the propeller and the motor? Well, to make our boat sail more efficiently, the propeller must be placed far below the boat. However, the motor itself is located inside the boat. So a direct connection simply isn't possible. So that's why we use a combination of shafts and gears to transfer the motion from the motor inside the boat to the propeller, allowing us to drive our boat forward. So now that you know how we propel our boat forward, Olivier and Roman will tell you how we make our boat sail as efficiently as possible.
Thank you, Hessel. Hi, everyone. My name is Olivier, and together with Roman, we are responsible for making the boat sail as efficiently as possible. And we do that by using a hydrofoiling system on our boat. Whenever our boat moves through the water, it experiences drag, which you can compare to the headwind you feel when you ride on your bike. The faster you go, the more drag we have, and coupled with a much heavier boat that we have, this results in a lot of extra power needed to sail. So, Roman, how do we solve this problem?
Thank you, Oliver. The most effective way to reduce drag is to let the least amount of boat touch the water. In other words, we need to raise the boat out of the water. You might know how wings lift airplanes into the sky. Well, since air and water are both fluids, they follow the same laws of physics. That means we can also fly underwater. We can do this by positioning wings under the boat, which are called hydrofoils. 3 hydrofoils of this exact size will be enough to support our 1,000 kilogram boat, which we find to be quite impressive. Exactly. With the hull out of the water, we can travel much faster and much further than a traditional boat would. To achieve this, we would have to design and build every part of our new hydrofoiling system. This includes the hydrofoils, the hinges, and the struts. And since the boat is much heavier than before, the forces we are dealing with are much higher as well, and something that our team has never dealt with before. It's a tough challenge, but we are more than ready for it. The faster our boat flies, the more lift gets generated by our hydrofoils. And since the weight of the boat doesn't change, we need to wait to adjust it. And this is done with our new hinging mechanism. It allows us to rotate the foil, hence adjust the lift. This hinging mechanism will get integrated into our new carbon fiber struts, which are going to be slightly under 2 meters long. But, Olivia, why do we need such long struts in the first place?
Well, like we mentioned before, we will be sailing in open sea this time, where the waves are much higher than anything our previous boats have encountered before. When those waves would hit the bottom of the hull, they would increase drag by a lot, which is of course something we don't want. With those longer struts, we'll sail safely above the waves and fly undisturbed. Above the struts in the hull is a mechanism that rotates the foils. Through the strut is a push-pull rod, which rotates the hinge and therefore rotates the foils. This rod is driven by an assembly, which is in turn powered by a very quick and accurate motor. But to know how the foils should move, meaning when to lift, when to adjust, and how do we keep the boat stable, we need something else. And for that, I would like to welcome Jim from Control to the stage.
Yes, thank you, Olivier. Hi, I'm Jim, and I'm this year's control engineer. So let's talk about control. And this is usually the part where half of the audience stops pretending that they understand. Except Michiel here in the audience. Trust me, he knows control. But don't worry, I'll try to make it as simple as possible. Let's talk about how we control these hydrofoils to achieve our goals. Because our goal this year is clear. We want to foil on the open sea. But as said before, the open sea is a challenging place to race. Because it's an open sea, you get very much wave disturbance, and that makes it very complex. So for this, accurate hydrofoil control is very important to keep the boat level and flying at high speeds. But how do we actually do control? In our case, you can think of it as an autopilot. The autopilot changes the angle of the wing in order to control the roll, which is the sidewards motion of the boat, the height, which is the upwards and downwards motion of the boat, and lastly, if we look to the side, the pitch, which is the tilting forward and backwards motion of the boat. When this autopilot works well, the boat stays level even when flying at high speeds, without the pilot having to do anything. But, as said before, we're working with a completely new platform. As structural mentioned to you, we have a new hull, and with that comes more weight, but also more power and higher speeds. And thus, the boat of this year behaves very differently on the water. And so, for this year, we will make a new control system which is specifically designed for the new boat and its corresponding characteristics. To deal with the rough sea conditions, we have included sonars at the front of the boat. And for this year, we've upgraded from 3 to 5 sonars. These sonars send out a sound wave and listen for the echo back. From this information, we can deduce what the wave height and shape under the boat are. This is similar to what bats do. Only difference is that bats have 1 sonar and we have 5. Next to that, we also have a motion sensor located in the middle of the boat. This motion sensor measures how the boat is moving and tilted above the water. This information of the sonar and motion sensor then gets fed into a common algorithm, which is a smart algorithm which tells us exactly what the boat is doing on the water, even when the situation is tough. And with this information that we get from the Kalman filter, we can adjust the angle of the foils up to 100 times per second, allowing us to stay stable and smooth even when flying at high speeds. But all of this, the estimating, the sensing and controlling, is done within the software compartment. And that is where the core of our control system lies. But to tell you more about the software systems on our boat, I would like to ask our software engineers, Andries, Jan and Wessel to the stage.
Hello everyone. My name is Andries Jan, and as you can see, I had a pretty drastic haircut this year. Together with Wessel, we are responsible for the software on this year's boat. The software processes the data from onboard sensors and uses it to make split-second decisions. Kind of like software is the brain of our boat. The team of last year did a great job writing software for their boat. We will be reusing a lot of the same software, but there will be some changes. So, first of all, we will not be using solar panels anymore, so we will get rid of those and replace them with the fuel cell. Next to this, we will also, the battery of last year will also be used to power the auxiliary system. Then, in the drivetrain, we will have a new and more powerful motor and the new battery. Next to these big changes, there are also several smaller changes in the auxiliary system, such as the addition of a new display and the addition of 2 sonars. As you can see, there are a lot of changes to the devices this year. For each device that has changed, the software needs to be updated as well. This will be the main task of our sub-team this year. There is, however, another task for our sub-team this year, which is safety. Safety is especially important since this is the first year we will be using a fuel cell and a high voltage system. So Wessel, can you tell me more about how we ensure the safety on board of this year's boat?
Yes, of course, AJ. As we have a lot of new devices this year, we have a lot of new challenges regarding the safety of our pilots. To summarize, we have the risk of working with a high voltage system, as well as the risk of a fire breaking out. So how will we mitigate these risks as best as possible? You're already familiar with the electrical overview of our boat, but let's zoom out a bit. When looking at our current electrical overview, we will implement a safety system which monitors the high voltage lines of the boat. In case of a high voltage emergency, the safety system automatically cuts off the power to the specific system. This way we can be sure that the boat is safe to handle. In case of a larger emergency, such as a fire, the easily accessible emergency switch can be used to disengage the entire electrical circuit. This way the boat can handle any situation as safe as possible. Now that the safety system is in place, the boat is finished and ready to transition to methanol. However, there are a lot of other things that need to happen if we want to transition as a team. And therefore I would like to ask Margot to the stage, who will explain how she coordinates the team during this transition.
Thank you, Wessel and André-Jan. Hello, everyone. My name is Margot, and I'm this year's transition coordinator. As my teammates have just explained, this year marks a major step for our team. But of course, this transition does not just affect our technical direction. Winning first place with our brand new methanol boat, while still being called Solar Boat Twente, would raise some eyebrows. And that is why we are moving into a new team identity this year. My role is to coordinate this process from start to finish. And to do this, I've divided the process into 3 phases. The first phase focuses on creating our new team identity. This is where our new team name and new team logo are created. The second phase focuses on planning our transition. Here, we map all the different places our brand appears, who our partners are, and how we can communicate our story in a clear and concise way. The third and final phase is the actual rollout, implementing all the rebranding steps to introduce our new identity to our partners, our peers, the broader public, and of course, the maritime community. I can see some of you are getting very excited about our new identity, so if you are, please do come to the boat reveal in May. Throughout these phases, I closely collaborate with the entire team to ensure our transition is not just something practical, but something that the entire team can actually stand behind. And while our identity transition shapes how we present ourselves to the outside world, communication is ultimately about sharing our story in a clear and consistent way. To tell you more about how we do this, I would like to call Twan to the stage.
Thank you, Margot. My name is Twan, and together with Toon, we are responsible for the public relations, graphics, and education this year. At Solar Boat Twente, it is our mission to inspire the maritime sector to become more sustainable. It is therefore important that our story is told. We do this by making sure that we have a strong online presence, both on Instagram and LinkedIn, and that we send out a monthly newsletter. Besides our social presence, you might have also seen us at big exhibitions such as Europort or Medstrade, where we got the opportunity to share our vision. We are very excited this year to share our new identity and of course our switch to methanol, so please stay tuned till the boat review. Besides my role in public relations, we also continue our efforts in educational activities, where we inspire our younger engineers to the wonderful world of innovation. We do this by visiting educational events, where we give interactive workshops, and by collaborating with schools in the region for a fun educational project. But the biggest PR event is, of course, our race at the end of the year. And for this, I would like to once again welcome management.
Yes, thank you, Ton. Indeed, this year we will go to the biggest stage of boat races in the world. We will return to compete in the Monaco Energy Boat Challenge. Since the founding of our team, we have participated in this event, but sadly last year did not have a suitable class for us to join anymore with our solo boat. But now, with our new boat, we can join the master class of this event, the Sea Lab class. This race will test the endurance, top speed and turning ability of our new boat. This class, specifically, stimulates sustainable fuels and leaves a lot of room within the regulations for innovative solutions to achieve performance. Specifically at our request, the race organization has changed the regulations to accept green methanol as a suitable fuel.
In addition to our race in Monaco, we also have the ambition to host our own event at the end of the year, bringing together partners, supporters and innovators to present our progress and share our mission. This event, as well as the race in Monaco, push us and motivate us to keep advancing maritime technology.
Over the years, we have mastered the power of the sun. But today, we are making a pivot by trading the sun for methanol. We will now share with you our 4-year roadmap outlining our path towards a sustainable future.
So, this year we exchanged the solar panels with the methanol fuel cell system. It's the first ever student team to do so. Like we mentioned before, this boat will be a proof of concept and serve as the groundwork for our future. By designing a new hull that will be produced somewhere next year and starting research on a more powerful fuel cell system, we're not only laying the foundation, but building the first bricks of the future.
Next year, we want to continue to build further on the foundation we are laying today. We aim to create the first custom-built hull designed specifically for this new era of sustainable sailing. But the real evolution lies within carbon capture. Our ambition is to be the first student team to capture CO2 directly from the fuel cell and use this to create methanol. This technique redefines what sustainable sailing can be.
In September of 2027, it's time to scale up. We will move from our current 5 kilowatt methanol fuel cell to a much more powerful 20 kilowatt system. Additionally, we also have the ambition to develop our own test facilities and bring this power again to the world stage, proving that sustainability and high performance racing go hand in hand.
At the end of our 4-year roadmap by 2028-29, we hope to have built a foiling race boat with an in-house designed and developed 20 kilowatt methanol fuel system with integrated carbon capture. We hope that this boat will serve as a blueprint for the future of the maritime sector. From the Twente Canal to the international waters, we hope to inspire the maritime sector to keep on innovating, just like we do.
This isn't just about building faster boats. It's about accelerating the energy transition. We have the team, the technical roadmap, and the plan. Now, we invite you to join us on this journey. Let's redefine the future of the maritime sector together. Thank you all for attending our presentation, and we would gladly like to invite you to join us for some drinks downstairs.